Okay, dear friends, we are going to see the last of this unit, that is the shortest path algorithm or Dijikstras algorithm for shortest path in a connected weighted directed graph. Now, let's imagine the same graph that we have seen. Okay, so directed weighted graph. Now we need to find out the shortest path from one point to another, S to T. Let S, the starting point, be A and the end point destination be E. Now in order to do this process, what we usually do by looking is the same process how the Dijikstras algorithm works. Now for every node in the graph, okay, uh, we use two labels. Okay. So we have a label. This marks the node from where a probe was made. A probe means, suppose I come to this node. Okay, if I come to node B, that means a probe was made from A, or I was traversing or coming from A. So that is this entry, the preceding node. And this is the shortest distance so far known from the starting node to that node. So first is a preceding node, next is the shortest distance so far. Now, so these are the two entries. Now look, so I'm starting from A. So A's distance from A to A is 0. So I have made this 0. And from where did I come? So this will remain blank. It is coming from here only. So for this node, for all other nodes, I make the shortest distance so far known as infinite. That means a huge value. I do not know what is the shortest path. So all these labels of other nodes are marked as an infinity, big value, just to find out the shortest distance. And the other second entry in the label is kept blank. We are going to. Then how does the program begin? Okay, so the program begins by traversing from here. This is my S, starts from here. Then I make a probe from here. Probe means I look into all its adjacent nodes. So there is B, D and C, means they are connected to B, C and D. And for every node that this is adjacent to A, then I go to the node B. Now here, from where does it come? Okay. So here it comes from B. So I make that entry B. So sorry, it comes from A. So that entry is made. So of course you can write it here. That is A. And now find the distance to B from A. 1. 1 is less than infinity. So what I do, I cut this. Okay, I cut this infinity because this is 1 is less than, then I enter that value 1. Okay, so that is shorter than this. So I have a new shorter distance to B from A than this value. Then look at the next node, this. Okay, so here it comes from where? It comes again here, it comes from A. So I enter A, and what is the distance? Distance to here is 4, and 4 is less than infinity. So I enter 4 here. 4. Okay. 4 is less than infinity. So 4. Similarly, the next node, of course, is good that you cut this so that this goes. And similarly here, from the next adjacent node, let's say probe is made from to the C, and here it comes from A. So I will make here A. So it is coming from A. So type A, and the value here now 5 is less than infinity. So cut this, and I will write here 5. So 5 is less. So all the probes are made from here, all adjacent node. Then having done this, so this was my working node before, and now I will look at the one that is nearest to A, or the shortest distance, and that becomes my current working node. So the next, for example, this is my shortest. This is 1, this is 4, this is 5. So this becomes a working node, and again I proceed from here and make the probe. So its neighbors only D. So probe is made from here. So when it comes here, okay, so comes here, the probe is distance to here is 1. 1 plus 2 is 3. 3 is less than 4. So which means I will cut this and I will cut also this. And now what happens? The new path that I came from is from B, and the distance is 2 plus 1, 3, the total distance. Since 3 is less than 4, it's fine. Okay. So that remains. Okay. That is a new value. Now, since only one we stop, then we take the next lowest nearest node from here. So if I take the next nearest so far distance is 3 itself. So I start probing from here. So let's imagine this becomes the working node. Okay. From here I do a probe. So from here it goes to C, okay, from D, and it is 2. So if you look this way, 2 plus, so the distance up to now is 3. So 3 plus 2, 5. 5 is not less than 5, so that is not changed. It remains. Okay. So both are same. That means if I come this way or if I come this way, the distance is same. So that need not. If it was less, of course, we would have corrected. So this does not get changed. Now it goes to its next neighbor. Okay. It comes here. And let's look here. So 2 plus 1, 3 is the current distance. 3 plus 2, 5. 5 is less than infinity. 5 is less than infinity. So we cut this. Okay, we cut this and we enter the value. So here it is coming from where? Coming from D. So coming from D, and distance is 2 plus 2, I mean only 3, 3 plus 2, 5. So the value is 5. And 5 is less than infinity, so I have this. Okay. So in fact, I have reached the destination, but we will wait. Okay, now, okay. So next, suppose this probing is over, then next in the list is this. Now from here, another probing can be done, that is from this node. Okay. So from this node, I do a probing, and from here there is only one to probe. So this is this. So distance to here is 5. So 5 plus 1, 6. And coming from C. So coming from C, 6 is greater than this, so we will not change. And from here, when this is become, the next node is this. I have reached the destination. That means my current working node is on E, which means now the shortest path which I have known is this. The shortest distance is 5 units, and comes from where? It comes from D, and D comes from B, B comes from A. So that is a path, A to B to E. That means if you look backwards, from E I reached from D, D I reached from B, B I reached from A, and distance is 1 plus 2 plus 2, 5. That means 2 is here, 1 is here, 1 plus 2, 3 is here, and 5. So this is how the algorithm works. Now, the process that we did now, okay, the process of probing, we have just explained using this method. Okay. So this is the probing. You can have a look what we have done, that is moving from one node to the other. I will post the algorithm with some explanation. This of course will need a little more of time and all that, but at least you are able to understand how the algorithm works, and given a graph how to find the shortest path. Of course it is also given